Welcome to Architech. This is Ritesh Srinivasan. In this video, I'll be explaining about text summarization. I'll explain about the TextRank algorithm and also demonstrate how you can implement text summarization using spaCy and gensim in Python. If you are new here and like such content, please subscribe to the channel. Let's get started. Let us look at what is text summarization. So a lot of text is continuously getting generated on the internet with a lot of new publications coming up, lot of papers coming up, lot of articles coming up. You have social media posts, right? Now, the summary of any text represents the most relevant information within the content, right? So if you have a paper which spans 4 to 6 pages, then you have an abstract which represents the summary of the text, right? Now, the process of generation of this summary of the text is known as text summarization. Okay. Now, you could do text summarization for a single document, or you can summarize multiple documents. Similarly, there are different methods for text summarization, which is extractive, abstractive, hybrid. We will be covering what these methods mean in the context of text summarization. Let us look at what is extractive text summarization. Now, by extractive text summarization, what we do is that we select important sentences from a document or a collection of documents to form a summary. Now, there could be different text information units. So, for the summarization, we could have information from words, from phrases, from sentences, from paragraphs. So, there are different algorithms to compute weights based on text information units to select sentences for summary. So, the advantage here is that the summary would be grammatically correct, but sequences of sentences which we have extracted from text may not be suitable for smooth reading. So here the whole emphasis is on extraction of certain sentences from the document which convey the information or which can convey the summary of the text. Now let us look at abstractive text summarization. So here what happens is that we build an intermediate semantic representation of the document. Then the summary is synthesized from the intermediate semantic representation. So here the summary may not be having the exact same sentences as the original content. The summary may use paraphrasing techniques. When we say paraphrasing, it is about saying the same thing in a different way, right? It's a very challenging problem to generate grammatically and semantically correct summaries. So this is abstractive text summarization. We also have hybrid text summarization methods. These use a combination of extractive and abstractive text summarization methods to generate a summary of the text. Let us look at some of the applications of text summarization. So we can use text summarization algorithms to generate news headlines. So you have news articles from which you can generate headlines. So if you look at this app in shorts, you have this news summary which is being presented over there. So this makes use of text summarization techniques. You can make use of text summarization techniques for question answering. So basically you have a question and the answer is present in the text document. So we can use summarization to get the answer from the text document. We can use text summarization for information extraction from, say, research papers, biomedical literature, or from financial reports. It is not limited only to these type of documents. It could also be documents from other domains. We can use text summarization to do product review summarization. So if we have long reviews, from the reviews we can extract a, or we can do abstractive text summarization and get a summary of the product review. Okay, so these are not the only applications of text summarization. There could be other applications also possible using text summarization techniques. Now let us look at one of the algorithms for extractive text summarization. This algorithm is known as TextRank algorithm, and for this task of automated summarization, what TextRank does is that it will model any document as a graph using sentences as nodes. Then there is a function to compute the similarity of sentences which is needed to build the edges in between these nodes. This function is used to weight the graph edge. The higher the similarity between sentences, the more important the edge between them will be in the graph. TextRank determines the relation of similarity between two sentences based on the content that both share. So the overlap is simply calculated as the number of common lexical tokens between them divided by the length of each to avoid promoting long sentences. So the idea here is that this algorithm TextRank, it determines the relation of similarity between two sentences just by looking at the number of common words between these two sentences and then divides it by the length of each of these sentences. So that's how similarity between sentences is computed over here. And this algorithm will model any document as a graph using sentences as nodes and the similarity between sentences as the weight of the edges between these nodes. Okay, so TextRank algorithm and its variations are explained in this particular paper. The link of the paper will be put in the description of the video. Let us look into a little bit detail about the sentence similarity metric used in the TextRank algorithm. So if you have two sentences Si and Sj, each having words like Si has W1 of I, W2 of I up to Wn of I. Similarly, Sj will have W1 of j, W2 of j up to Wn of j, right? The similarity function for these two sentences Si and Sj can be written as those words Wk, the count of words Wk, such that the word is present in both the sentences. That is what is over here. So the count of the words such that the words are common in both the sentences Si and Sj divided by the length of Si and Sj, but they have used the log of length of Si and log of length of Sj, right? So this is the similarity metric which they use, and using this similarity metric, a graph is constructed which represents the document. From this graph, basically, PageRank is used to compute the importance of each vertex. The most significant sentences are selected and presented in the same order as they appear in the document as the summary of the document. So this is what is happening in the TextRank algorithm. Okay. Let us look at the PageRank algorithm. So PageRank is an algorithm used by Google search to rank web pages in their search engine results. PageRank was named after Larry Page, who is one of the founders of Google. It is a way of measuring the importance of website pages. Okay. So what does this algorithm do? It outputs a probability distribution used to represent the likelihood that a person randomly clicking on links will arrive at a particular page. Okay. So PageRank can be calculated for collection of documents of any size. It is assumed that the distribution is evenly divided among all the documents in the collection at the beginning of the computational process. Okay. So the PageRank computations require several passes called iterations through the collection to adjust approximate PageRank values to more closely reflect the theoretical true value, the true likelihood that a person randomly clicking on links will arrive at any particular page. For more details, you can look at this particular website. I'll also be explaining PageRank with an example. Let us look at an example of the PageRank algorithm. Suppose if we have four pages A, B, C, D. Okay, these are four website pages. Okay, now if you look over here, page A has an incoming link from the page C, from page B and page D. Okay, now page B has an incoming link from page D, but it has outgoing links from itself to page A and page C. Okay, and page D has only outgoing links to all the other pages, which is A, B, C. Now this can be represented by a transition matrix. Okay, so if you look at this matrix, you will find that there is a link between page B and page A. Similarly, page C and page A, between page D and page A. Likewise, there are links for the other pages over here. Okay, at the start of this algorithm, each of these pages has a equal probability whereby a person would land from a random link onto any one of these pages. So we have equal probability, which is 1 by 4, which is 0.25. Okay. Now let us see what happens next. Let us look at the implementation of the PageRank algorithm. So this is the Python implementation. So the PageRank theory holds that an imaginary surfer who is randomly clicking on links will eventually stop clicking. The probability at any step that the person will continue is a damping factor D. So in various studies, the value of D was found out to be 0.85. So what does the PageRank algorithm take as input? It takes as input the transition matrix, which is basically the transition matrix of the pages. It takes a stopping criterion or an epsilon value, and then it takes the damping factor. Okay. So at the start of the algorithm, the probability for all the pages is initialized as follows, and which is shown over here, right? Then what happens is that a new probability is computed for every iteration, which is nothing but 1 minus d divided by the total number of pages plus d star, which is d multiplied by the transition matrix and dot product with the probability vector. Okay, so this is what is done over here. This gives you the new probability. Now then you look at the delta value, which is the new probability minus the old probability. Now if this value is less than the stopping criterion, we return this new probability. So after some iterations, what happens is that this new probability will be stable, and it kind of represents the final probability or the page rank of each of these pages. Okay, now let us look at the results of our implementation on this particular transition matrix. As I said, the input for the page rank is our transition matrix. The initialization of the pages is shown over here, the initial probability. Now, after a couple of iterations or many iterations, what happens is that the new probability kind of becomes stable, and this is the final new probability which is obtained. So, if you look over here, page A has a ranking value of 0.23, which is the probability. Page B is 0.06, page C is 0.12, page B is 0.03. Now, when we sort this probability vector, this is what you get. So, in this particular case, the page A has the highest rank, followed by page C, then B, and finally D. Okay. Intuitively, the idea over here is that page A had the most number of incoming links and less number of outgoing links, and hence it is considered to be a very important page. Okay, and hence it has the higher rank. So this is a simple explanation of PageRank algorithm. For further details, you can look at this Wikipedia page. Now let us look at how we can use PageRank for TextRank algorithm. So in the PageRank, we had a transition matrix representing the links between the pages. So here we have a sentence similarity matrix, okay, which looks like this. So here we have four sentences, S1, S2, S3, S4. So this is a similarity value between these sentences. Now we can compute this similarity value using the longest common substring. We can use cosine distance. We can use the number of common words which are present in both these sentences. And then there are some measures like BM25, BM25 plus, which has been described in this particular paper, to actually compute the similarity between the sentences. And then we create this sentence similarity matrix. Okay. So if you look over here, the diagonal is 0 because the similarity between the same sentence, we don't consider it over here. Okay. So now if you have this similarity matrix which has been computed, the sentence similarity matrix, then we'll go and apply PageRank. So as seen before, what is done is that you have an initial probability matrix, and then you have the damping factor, and you run the algorithm, and you finally get the final probability values for each of these sentences over here. So if you look over here with this particular sentence similarity matrix, we have got this as our results. Okay. So now what we do is that we will sort these sentences based on PageRank score. So what happens is that when you sort this, you will get S4 first, then you will get S1, then you will get S3, and finally S2. Okay. Now we will extract top n sentences. For example, for the summary, so in our case over here, if n is equal to 2, then we will extract sentence 4 and sentence 1 and say that this is a good summary for our document. Okay, so this is how PageRank is used within the TextRank algorithm for extracting the top n sentences based on their PageRank score, which is derived from the sentence similarity matrix. Okay, for further details, you can look at this particular paper for the various measures for computing similarity between sentences. Let us look at how we can perform text summarization with spaCy library and TextRank basically. So for this, we first import the packages. We import spaCy, we import pytextrank. We create a spaCy pipeline, NLP pipeline, by loading one of the default models. So I've used the medium-sized model over here. We create an object of the pytextrank. Then we add the pipeline component of this pytextrank object to the NLP pipeline like this. Okay. Then what we do is that we define some text over here. So basically I pulled from Wikipedia about the car company Ferrari, a certain set of lines over here as our text. All we have to do is that we have to just pass the text to our NLP pipeline, which gives a document as an output. Now in that document, you can examine the top ranked phrases in the document. For example, we have to just do for phrase in doc dot underscore dot phrases. You can print the phrases, their rank, their count in that this thing, and also the text where it is present. So for example, if you look over here in this particular example, you can see over here that you have Scuderia Ferrari coming many number of times as a phrase, right? And this is the rank or the probability value, and the number of time it appears is 7. So if we have not pre-processed the text, so that's why you are seeing words like Scuderia, Ferrari, and again the same words, right? Then you also see words like Enzo Ferrari. So this is the phrases, right? Now let us look at summary of this particular text. For that, what we do is that we extract the sentences from this doc.textrank.summary, and we say we limit the phrases equal to 15 and limit sentences is equal to 5. So we want 5 sentences as summary over here. So this is the summary of the text. So for example, it has picked up some history over here, like Alfa Romeo bought its racing operation again in-house, forming Alfa Corse in Milan, and hired Enzo Ferrari as manager of the new racing department. Therefore, the Scuderia Ferrari was disbanded. In September 1939, Ferrari left Alfa Romeo under the provision he would not use the Ferrari name, right? Then there is some other text coming from here saying that in 1988, Enzo Ferrari oversaw the launch of the Ferrari F40. Then some recent text from 2002 to 2004, Ferrari produced the Enzo, their fastest model at the time, which was introduced and named in the honor of the company's founder, Enzo Ferrari. So this has actually kind of built a summary over here. We have set the sentences as 5 sentences. So we have got this summary of the text. So this particular Python package, which is pytextrank, implements the TextRank algorithm, and this can be added as a pipeline component in the spaCy NLP pipeline. So that is what has been demonstrated over here. It is as simple as just adding the component to the pipeline, the pytextrank component to the pipeline, and passing the text for which you need to get the summary. So in our example over here, we are doing a single document summarization. If you have multiple documents, if you combine the sentences of the multiple document into one single document, and you can pass it to this NLP pipeline to get a summary. Okay. Now let us look at how can we do text summarization with the gensim package. Okay. For this, it is again very simple. We have to just import from gensim.summarization. We have to import summarize. Okay. Then we just pass our text to this summarize class. Okay. So again, I pass the same text, and it actually gives you a summary over here. By default, what it does is that it gives a summary having sentences up to 0.2% of the total length of the text. For example, if you have 100 sentences in your text, you will get a summary with top 20 sentences as the summary. Again, internally it uses TextRank algorithm with certain modifications on the similarity measure. Okay, so this it prints as one continuous this thing. If you do summarize text and split is equal to true, it will print the sentences. It will split the sentences and print it like this. If you do summarize text ratio is equal to 0.5, that means that if you have 100 sentences in your text, it will print out the top 50 sentences as the which it has found from the TextRank algorithm as the summary. Okay, so you see the larger summary. Similarly, you can restrict the summary saying that I want the summary to be within 100 words. Okay, so you can call summarize text with word count is equal to 100. So you get a smaller summary over here with up to 100 words. Okay, you can also print the keywords for this particular text. So for example, if you import from gensim.summarization, if you import keywords and pass the text, it prints the keywords saying that these are the important keywords like Ferrari, racing, races, Romeo, race, car manufacturer, and so on. Okay, these are the important keywords in our text. So we can use this summarize from gensim to actually summarize our text, or we can use spaCy with pytextrank to actually get summaries from our text. Both uses TextRank algorithms for summarization, basically the TextRank algorithm for the summarization, and both can give you the summary of the text. If you like such content, please like the video, please share the video, please subscribe to the channel, please press the bell icon so that you will get notified whenever I am creating a new video. See you in the next video. Bye for now.